Hello, everyone. I'm Mark Bay. I'm one of the market segment managers with Makino. We are up here at Makino Center of Excellence in Auburn Hills, Michigan.
I'm Taylor Cox, Senior EDM Applications Engineer.
So, Taylor, today we're going to look at the process of programming and setting up a part and making some decisions based on a print that you would get from engineering typically. And so it's going to be stamping punch.
Yep.
And if you want to look at the sample print here,
Sure.
If you can let us know and walk through like some of the considerations that you would have when making your decisions on, which wire to use and so forth.
Okay. Sure. So one of the first things that I look at when I'm looking at wire EDMing a part, the accuracy that's required, the tolerance, and the surface finish.
What kind of impacts on your decision process do those have?
Number one, machine platform, right? If it's a very tight tolerance part, we may look at using a different machine. As far as surface finish, really that's just cycle time, how many passes we're going to be running, and potentially what wire to use.
Okay. So the better the surface finish, the more passes, the longer it's going to take.
Correct.
The more expensive the part gets.
Correct.
So I think what you're getting to is like finding the right balance, right, between what the requirement is and how you approach that.
That's correct. It's all about the balance. You don't want to have a part that's obviously not to tolerance, not to print, but you also don't want to over-engineer your parts because that's just more time and more money that, you're throwing out the window if it's above and beyond.
And I think that can be a danger, right? Because I think what we sometimes see in shops, that shops make a decision based on some, let's say, standard parameters that they have set. So maybe they will go with 3-pass machining when maybe it's not required.
I see that quite commonly. A lot of people have a standard, whether it's 3-pass or 5-pass, they apply that to everything that they do. Maybe some parts don't need that. They need a 1, 2-pass, 3-pass. So you're spending all this extra time, money, wire on cutting those parts that don't need to be. So it's always good to really look at specifically what the part requires and program to that.
Yeah. Okay. So when you start looking at a print, again, in this example, it's stamping punch.
Yes.
So walk us through a little bit through your thought process and decision-making process that gets you, to the machining platform, to the wire, and to some of the settings.
Yeah, absolutely. So the first thing that I look at is material type, right? This is D2 tool steel, 58 to 60. So very common to cut on wire EDM machines. We know that it's going to be pretty stable material. It's not going to move all over the place. Next thing I look at is the tolerance, the accuracy of the part itself. The tightest on this print is plus or minus 1 thou. So in the wire EDM world, that's relatively open. We could do that with 1-pass machining, specifically based on the accuracy.
The
next thing is surface finish. Okay. So this is about a 50 micro-inch RA. So accuracy, we could do this in 1 pass, but the surface finish dictates, right? This is going to be, about a 3-pass machining. Part thickness is going to be 4 inches. So typically when you're above the 2-3 inch thickness, typically if you go to a larger wire, your cut speeds are going to be faster. So the considerations on wire diameter size is really going to be the shape of the part. If you have any very small internal radii or some kind of crazy complex geometry, that typically limits you from going too large, similar to a mill, right? You don't use a giant tool to cut in on the small parts.
Would you sometimes consider that? I mean, I know in this particular part we don't have that case, but if you had a few features that were very tight, would you consider changing diameter as part of your overall process?
It can be done. It would really depend on the specific case
Yeah.
and how large the geometry is, how long the cut times are. Anytime you're doing multiple operations, you would have to consider the accuracy of that. Typically in wire EDM, what you do is you just go to that size wire and cut everything. So yeah, in this instance, what I would look at as far as accuracy, right? We said it's relatively wide open, 4-inch thick. So I'd use a large wire, 50 micro-inch RA. So I would look at using 12 thousandths wire for this because we can get to this 50 micro-inch RA surface finish with 12 thousandths wire. We have bigger wire that's available, but it won't be able to reach a surface finish. So 12 thousandths wire would be what I would use on this part.
So you mentioned the larger wire, so we're talking 16 thousandths, right?
Yes. Yep.
So you would be able to reach the tolerances, but you would not be reaching the surface finish.
Correct.
Okay.
Right. So I'd definitely be able to reach the tolerances on 16 wire on this part, but the surface finish, I cannot get down to that. But that's always an important conversation to have. You know, a lot of people have those default surface finishes on their print, right? So if the specific part doesn't need that surface finish, right? If I can cut this in 2 passes and I can cut it in 16 thousandths wire, then you're going to save time, you're going to save money, right?
So that's, I think, a really important point, not just for the operator who's going to machine it or set up the machine, but also for engineering, right?
Absolutely.
And so in what cases would you typically see the higher surface finish requirements?
It depends, you know, typically in stamping, you've got, you know, fine blanking, you've got your tighter tolerances, finer finish, lifetime of the punch. So typically better surface finishes, the punch is going to last longer.
So for like a 24/7
production type stuff, you typically run those better finishes where you don't want to shut down the operation to keep replacing parts. You know, if it's relatively short run or not, you know, super high accuracy, you can get away with reducing the finish a little bit. So it definitely varies depending on what you're working on.
So definitely important aspects to consider when you go into designing the part and the print, inspecting it out.
Absolutely. Surface finish is critical.
Yeah.
Because that's going to dictate the technology that we use.
Yeah. All right, Taylor, is there a way that we can take a look at how you would do that on the control at the machine?
Yeah, absolutely. We'll look at a couple of things. I'll show you, you know, how I would go through and search and select the technology that's on the machine. And then also, you know, load up a program, show you what that looks like as well.
Okay,
so we'll
great.
go ahead and do
Thank
that
you.
then. So what we're going to do is now I'm going to show you how we're going to select and look at what technology we have loaded on the machine. So I'm going to go to the run screen here. Going to go to Active E-Tech. Find a card that's open or initialize a card. Then I'm going to click in here and I'm going to start off. In this instance, I've got 12 thousandths wire on my machine. I could open the filter to show more, but in this case, we've already got 12 loaded. So brass 12 thousandths wire, then material. We've got steel, copper, aluminum. I'm going to choose steel. So then scroll through, take a look at what thickness this is. And our print was showing 4 inches. So we'll select 4 inches. Then we're going to choose our technology.
And that's where I would have a question here, Taylor, is there are a lot of choices here.
Yep.
How do you know which one to pick? The other items are pretty much straightforward, dictated by the part geometry and thickness and the material, etc. But here are a bunch of options. Which one?
Yep. So in general, you have 2 different types of technology. You have away technology and close technology. So physically, if your part is flat top and bottom, like this part is, we can use sealed off nozzles that ride along the workpiece, that's going to give you faster speeds, right? Flushing's going to get in, remove the debris. That's always going to be faster. So we have that category, and then we have a both away category where the nozzles are physically not touching the part. Then inside, the specific technology is really going to dictate which technology that you choose, right? If I'm focusing on speed only, right, then I could choose something like a high speed, right? So that's going to be a sealed off nozzle, high speed. If I click on this, you can see it limits the surface finish. We're focusing on high speed, so we're not focusing on good finish.
So that's a good point, because I was going to ask what happens if you choose the wrong one.
Correct.
So
Yep.
it actually shows you the limits of what it can do, and then you just backtrack and
Absolutely. So you can look through anything that says both away in front of it is going to be nozzles away, right? Anything that does not say, right, all of those are going to be sealed off nozzles. So in this instance, yes, parts flat top and bottom, we're going to use sealed off nozzles. When you'd want to use both away, physically, if the part's not, flat top and bottom, or you can't access that, or if you've got small intricate geometry, you would use the both away. So in this instance, right, I would use precision, right, because we're going to be doing 3-pass machining. We'll check in here. So inside precision, you can see we can go all the way down to 5. High precision would be really higher accuracy, mostly in corners, things of that nature. Okay, so then the next thing that I'd do is I would select the surface finish. So finish 50, so 50 microinch RA. I hit select, and then the big key thing is you have to hit the search button here. So hit the search button, and then you'll see that all the technology is shown up. And then also it shows you a picture of the nozzles on the screen. So the little rubber insert nozzles, and basically they're going to be about 20 thousandths away from the part. So they're going to be riding on the part themselves. Okay. So that's how you would select, or how you could look through technology at the machine to see what you have available. What we can do now is we'll go through, I'll load a program. That same thing, that same selection you would do in your cam system. So your cam system, you would select the wire type, diameter, all of those things. So I'll load a program that already has all of these codes in it. Okay. So we'll go ahead and do that now. Get out my USB here. Load our USB into the machine, and then open the program page. So program, file manage. So this is going to be where you're going to import, export programs. So I'll select my USB. It's the only program I have on this USB. So I'm going to import it. Now the program is in here. If I open it, we can take a look. So we've already got all of our offsets. We've already got all of our E codes, our E 4-digit numbers there. So second pass and third pass. And then the program ends. And then what we can do is we can graph it out on the screen just to make sure it looks correct. So we've got this graphed out. And then we can watch our graphics here. So you can see all 3 passes, you can see. So that's how I would choose, how I would select technology. You can use a machine to look through. You can also do that in your cam system as well. So that's going to go through selecting all this stuff, drawing that out, loading it into the machine. From there, we'd go physically setting the machine up, getting the part in the work holding, everything else, and then actually running the job.
Taylor, thank you again for taking us through this process. And when we started the conversation, right, we talked about balancing different requirements: accuracy, tolerance, surface finish, cutting times, etc. So I think you brought some examples here.
I did, right? I brought 2 examples. The one here, we have basically what we just went through, right? Several skin passes, right? You can see the surface finish is much better. This is an example of just a rough cut. So what we talked about earlier is if we didn't need that surface finish, we could get this done in one pass only, where we did this one in 3 passes, right? This would save us time and money. But that's really where you need to understand what the requirements of the part, what the part functionality is, and then really decide what's best for you, right? But this is kind of a side-by-side example of that difference.
Great, thank you. Thank you everybody for attending. We'll open it up now to the audience for a Q&A, and looking forward to taking your questions. Thank you very much. Thanks, Taylor.
Thank you.
Okay. Thank you very much, Mark and Taylor. My name is Brian Coward. I'm the EDM product manager at Makino. If you have any questions about the part we just looked at, or any part processing in general, I'm available to answer any questions that you might have. You can type them in either the chat there or the Q&A section. So first, I want to kind of emphasize a little bit what Taylor was touching on there in terms of processing the job and surface finishes, and why it's important sometimes to maybe go back to engineering and say, hey, is this surface finish really required on this part? And so this is the actual part that Taylor was demonstrating. And this was a part that we did do for a customer. And this is an instance where we went back to him and said, hey, is it really necessary based on your accuracy here that you need that surface finish? They came back and said, no, it's not really necessary. We could go with a one pass surface finish. So when we do that, we were able to take that to the H.E.A.T Extreme machine, which has our 16 thou wire diameter option available on it. And to show you the impact of that, they were in the past, they were doing this part with a 10 thou brass wire, and it was taking them almost 5 hours to do this punch. By doing it with the 16 thou diameter heat wire, with the heat settings, we got it down to just over 2 hours. So it is quite an impact when you're talking about the surface finish requirement there. So it's sometimes it's required, and so you're going to have the extra passes. But in this instance, it wasn't, and it was able to save them a considerable amount of time. Okay, looks like we have a question here about how long did it take to make that part, and how many inches per minute did you get through the rough cut? Okay, so Dylan, I basically answered that question on that last slide. That's essentially what it is. I don't have the inches per minute detailed numbers on there. I'd have to circle back and get that to you, which I could, but that last slide there just shows you the difference. Now, the original test cut there was done in 10 thou as opposed to 12 thou. If we do that part in 12 thou, which we did do in the rough cut, that rough cut was down to about it was right around just under 4 hours. So even at that, we were around the 4 hour time frame with 12 thou. We go to that 16 thou, makes a huge difference in terms of the cut speed that we can get. All right, I did have one other question here that somebody sent to me. When Taylor was going through the technology selections, question came in is, what does the BAHS parentheses heat technology, what does that mean? Well, so that is what we refer to as our heat technology. The BAHS refers to both the way high speed. So just like we have the high speed technology for sealed off, this would be both the way high speed. And what that's doing is utilizing the large pumps that Makino has. And we're able to flush with high pressure, even though we're unsealed, which is what allows us to increase our machining speed and decrease our overall processing time. So that's the specific technology. We have very, like I think Taylor did a good job explaining the difference in the technology. You got sealed off and unsealed. And then inside of the sealed and unsealed, we have categories of different types of technology. So like high speed, precision, high precision. And so if there's ever a question, always feel free to ask us what the differences are. But as Taylor pointed out, high speed is just that, is for speed. Precision is going to be precision, better surface finishes. High precision, as Taylor referenced, again, is a precision, but the corner accuracy might be increased a little bit. There's a little adjustment on the corner. So if you had really small corners, and small internal radii, that's when you would go with that high precision setting. All right, we got another one here. What was used to hold the part? That's a good question. And that's a really good question. And how do you manage the slug? Okay, so that particular part, even though it was just drawn up individual, on the print there, that's just the part print. So essentially, this was cut out of a block, and then we tagged it on the one side, and we had a pretty good size tag on there. And so typically the way you're going to manage this slug, so on the flat end of that punch is where we would place the tag. And we're just going to cut that out of just a square block of steel. And so that whole part will come out. And then the tag, so even, for example, the 3-pass one, right? So we're going to have to leave the tag to skim cut it, right? If it's one cut, it's no big deal. We just go around, come to a stop, and then you cut it off, right? Because it's just one pass. 3-pass, you're going to need to skim cut it. So you want to leave a tag to hold that part. And then we're going to do the 2 skim cuts, and then we'll go in there. And typically the way we'll do it is we'll 1-pass the tag and leave a little extra stock on there. And then we'll take it over to the surface grinder and grind that tag off and blend it into some reference surfaces that we've left on that flat side. So that's the most common way to do it, and probably the most efficient way to do it in terms of machining time. Now you can skim that tag if you want. And in that instance, then we're going to have to secure that slug, as Dylan's talking about, to be able to skim cut it, which we can do. So for something this large, it's a pretty big part. Typically what I would do is I would have the tag, like I said, on the one end, the far end where the flat end that you can see on the print there. And then I would actually just put a C-clamp, like a can't twist C-clamp on the other end. And I could clamp that down as long as it's not going to interfere with my head or hit anything on my head, which it shouldn't, because this part is long enough, right? So I would clamp on the far end, and then I'd have a tag on the complete opposite end, and I could go in there and I could skim cut that back and forth and remove that tag. So that's the most common way. Smaller slugs, that's a little more of a challenge, where you're gonna, if you want to skim that tab, a way that I've done it in the past is you can actually fill in the kerf with some Bondo or super glue, something like that. Now the only downside there is then you got to clean that off after the fact, but you can. It's not impossible to be able to clean that off. Okay. Well, if there are no more questions, I want to thank everyone for taking a little time out today and spending it with us here. If you have any more questions or anything, please feel free to contact myself or your local Makino representative, and we could set up a one-on-one meeting and have some further discussions with you. So thank you very much, and everyone have a great day.